This is BaslerCast, tutorials for Mr. Basler's physics class. This episode of BaslerCast is going to look at energy. Energy is a very big topic in physics. It's also a very big topic in our day-to-day lives. It shapes how we live each day. Every day we are affected by energy. This episode is going to look at the very basics of energy, the key terms, the key definitions, the key formulas. These are things that you have most likely have been introduced to in a previous class. And the intent of this podcast is to be a review or a refresher of those key terms. So let's get started with a basic introduction to energy.
Turns out that energy is defined by saying it's the ability to do work, which brings us to a definition: what is work? Work is when a force is exerted over a distance and we have force times the distance, that equals work. Now, there are units for work. Since it's force times distance, it would be newtons times meters, which is a newton meter. 1 newton meter is equal to 1 joule. There are two major types of energy. It's kinetic energy and potential energy. Now, we talk a lot about kinetic energy, and then we also talk about the forms of potential energy. First, we'll talk about kinetic energy. Kinetic energy is dependent on how fast an object is going and its mass. The faster it goes, the higher the kinetic energy. The slower it goes, the lower its kinetic energy. When we talk about potential energy, there are different forms. There's energy that's stored up, and that can be gravitational potential energy. In that case, the force is the weight, and the distance is the height. You can have chemical energy stored up in gasoline, batteries, different things like that. You can have elastic energy, and in that case, if we deal with the spring, the force is the spring force, and the distance is the displacement of the spring, or the stretch of the spring. We have been looking at how to keep track of the energy transfers, and energy can be kept track of when we have a bar graph. In this case, we have a car that's traveling at a speed. It hits the brakes and its energy leaves. It's gone. But we call that dissipated energy because that's energy that leaves the system. It didn't disappear, but it left the car in the road, which is the system. It leaves through forms such as heat, sound, light, different things like that. And the key thing is to stress that we don't lose the energy overall. It just leaves one system and goes to another. The other thing we can do other than bar graphs is pie graphs. We can symbolize or keep track of the energy by using a pie graph. In this case, we have a block on a ramp. In the beginning, the bulk of the energy is gravitational potential with a little bit of kinetic energy. Now, it's gravitational potential because it has a height, and it's a little bit kinetic because it's going at some speed. In the next scene, we have gravitational potential going down because it's not as high. We have more kinetic because it's allowed to speed up. So some of this gravitational potential energy that was here got converted into kinetic energy. So like this part here got converted into kinetic. And then also because there was some friction, we have some energy that's leaving the system or dissipated. And then lastly, we have the thing going as fast, the crate going as fast as it can be. It's at its lowest point, so there is no gravitational potential energy, so it's all kinetic, it's sped up, and then the rest is dissipated.
So there you go, a very basic look at energy. However, it's very incomplete. You must keep in mind that what you really need to know about energy involves its implications and applications around the world. That's what we'll try to flush out in class. Thanks for watching.